So welcome back to association rules for market basket analysis and the grocery data set that we're working with. We've read it in as a sparse matrix, we inspected it a little bit, and now we want to kind of go a little deeper. Let's inspect the transactions. So in a sparse matrix, you don't want the way you actually see the transactions or the rows is by inspecting them. So rather than just typing what we're used to, which is the name of the data frame, and then in square brackets some kind of indexes for the rows and the columns, in a sparse matrix you must inspect. So we inspect groceries. Okay, and if we inspect the entire 10,000 transactions, we're going to get a lot of output. So let's only inspect the first 3. Okay, so you can control which ones you're looking at. You can look at the third, you could look at the 9,000th to the 9,005th, whatever you need. That's how you control it. Okay, so we call this from when we looked at the original raw data that the first transaction was for citrus fruit, margarine, ready soups, and semi-finished bread. That definitely rings a bell for me. And you see these squiggly brackets, that's set notation. The next transaction was for coffee, tropical fruit, and yogurt. And notice that they're kind of ordered in alphabetically where they weren't in the raw data. Third transaction was just for whole milk. So I remember these, so that's nice. So this is how the data is recorded. If I want to ever inspect any of the transactions, I can use inspect to look at them like this. Okay. The next thing I want to do is to talk about something more related to association rules, something called support. Okay, the support is lingo used in association rules for how frequently an item occurs in the data. Okay, so in other words, in what percentage or what proportion of transactions does a particular item show up? So for example, if whole milk is in half of the transactions, then the support for whole milk would be 50%. So let's take a look at the item frequencies. The supports. And to look at that, we can use item frequency. And then within the parentheses, we can look at particular items. So groceries, so let's look at the first item. Okay, so the first item alphabetically I think was abrasive cleaners. Right, abrasive cleaner has a support of less than 3%, well, let's say less than 1%, right? Because if you move this over, it's 0.3.5%, 0.35%. So it shows up in 0.35 of transactions. To just put a number on that, let's multiply that by the number of transactions. So it shows up in about 35 transactions. Okay? So we don't know yet if that's high support or not. It's relative. But let's take a look at some of the others. So you could see the first 6 items, 10 items, however you want. Notice I'm leaving this open, so I'm looking at all transactions. But these are where the features are in the columns. So I'm looking at the first 5 items alphabetically. And here are their supports. So we see that abrasive cleaner, we just saw that. Artificial sweeteners also has a pretty low support. Baby cosmetics doesn't show up that often in transactions. Baby food, bags, baking powder. 1.8 roughly percent. So that's not so low. Okay, but there's definitely items that have a higher support. So to see this, actually, you can make a graph, and you can actually, using the functionality, by the way, these functions all are in the arules package. So you need to load that. So item frequency plot will make a plot Okay, so we can look at all the transactions, all the items, rather than just the select few items, and we can specify a minimum support. So let's say let's only look at items that have 20% support. So they show up in 20% of transactions. Look, it's only whole milk. Okay, so maybe we should lower our minimum to see more things. Let's just look at items that that show up in a minimum of 10%. There we go. So have a minimum of 10% support. So let's look at this. Bottled water shows up in about 12%, it seems. Other vegetables, about 19%. Rolls and buns, and so on and so on. And whole milk, a little more than 25%. So again, the most frequent item. We saw that before when we looked at the summary. So this is one way you could look at the item frequencies, or in other words, this where support is high. Okay, so these are the items with the highest support. They have more than 10% support. Okay, so out of all 169 items, the item with the highest support is 25%. Maybe a little more than 25, but it's close. Yeah, roughly 25. Okay. Another way you can use the item frequency plot function is to actually specify, to show you the top 10, let's say, or however many, top 5 items. And by top 5 we mean the items that show up have the top 5 support. Okay, so that show up the most. So whole milk, and it disorders it. So whole milk is the item that shows up in most transactions, and its support you can read off the chart. Other vegetables, second. Rolls and buns, third. Soda, fourth. That's great, healthy. Yogurt, fifth. Okay, so these 5 items are the 5 items with the highest support, that should have the highest frequency in the data. Okay, I can change this to 10. I could change this to 20. Okay, so I'm getting this very easy to read bar chart. Okay, and it ranks them nicely for me. So that's nice. So that starts shedding some light on the data that we're looking at. Okay, another item before we go on to actually getting some association rules. We've learned what support is. So an item that has high support shows up frequently in the data. So whole milk was the one with the highest support. It showed up in the most transactions. There's a similar concept called confidence. Confidence is a measure of the proportion of transactions where the presence of an item or a set of items results in the presence of another set of items. Okay, so basically it's like conditional probability. So if I buy item A and item B, how likely is it that I'll also buy item C? So the confidence of A, B implying C is how likely is it that given I bought A and B that I'll also buy C. Okay, so the formula to calculate confidence, let's use this scenario. So confidence of A, B, and let me try to put this in set notation, resulting in a purchase of item C, or implying, is equal to the support of A, B, and C together. So, and what proportion of transactions do A, B, and C show up in over the support of the condition, which is AB. Okay? So I'm going to try to explain this in a couple other ways. So I'm just using A, B, and C as just 3 items. You can just imagine there's going to be a lot of different ways you can think of this with all the items that we have in this grocery store. But it's to illustrate the concept of confidence. Just take these 3 items. Okay? So to get the confidence of and let's think of this as a rule. Okay? AB implies C. So the confidence of that rule, so this is a rule, and this is kind of alluding to association rules. The confidence of a rule is equal to, you can think of it as, let's look at only the transactions in the data that have item A and B in them. Okay, so throw out all transactions that don't have A and B. Okay, so only looking at transactions that have item A and B. What proportion of those transactions also have item C? That's what's going on here. Okay, so we're looking at how many transactions of the transactions that have A and B have also C. Okay, and to get that, we could apply the support of ABC over the support of just AB. Okay, luckily we won't have to calculate this, but the rules that we look at, we would like to have high confidence. High confidence implies that a rule is likely to be kind of meaningful, that it has good predictive power and good accuracy. Okay, so ultimately we want to come up with association rules that have high support and high confidence. Okay, I didn't want to get into too much of the theory. I wanted to focus on the art, but I realized that as I'm doing this, that in order to have any kind of feel for what's going on, we need to roughly at least understand these 2 concepts. Okay, although because they're easy to relate to, the formulas and stuff, please kind of don't take this as a comprehensive illustration, exposition of this. Okay, so let's get back to what we're doing with the grocery data set. So at this point, we've imported data, we've played with it a little, we've looked at it in different angles, we know which items are frequent, which items perhaps are infrequent. We're looking for interesting patterns and relationships between items. So that boils down to items and item sets that have high support and rules that have high confidence. So if both of those things are satisfied, a rule would be kind of interesting for us to maybe look into and see. For example, something like peanut butter and jelly implies bread. So let's come up with these rules. In order to do this, we again use the arules package, and we're going to build a model. Let's call it M1. Okay, a priori, that's using the a priori property. Okay, so you can look into that at your own leisure. First thing we want to give it is the data set. So that's our grocer, it's our sparse matrix. Now if you were to leave it like this, you would be using the default values for a minimum support and minimum confidence, which are set at 0.1 for support and 0.8 for confidence, I believe. Okay, if we do this, we get some output here. Most interesting thing is M1 yielded no rules, so that's not useful. And the reason for that is because the minimums, the default minimums, were too stringent. So to make them to lower the minimums, we can define them ourselves. So the parameters, so we're going to set the minimum support to something in the neighborhood of 0.007, and the minimum confidence, instead of it being 0.8 or 80%, let's set it, sorry, did I put a let's put it at 10%, or actually let's do 25%. And let's also control the minimum length of a rule. So min length. We don't want rules that are one item. They're useless here. So let's make them at least 2 items. Okay, hit enter. I forgot a parentheses. Let's clean that up. So min len is the minimum length of a rule. Okay, we get all this output. Let's look at M1 now. So we see we have 363 rules. Okay, so we got a lot of rules now. All right, so we can work with this. One thing we could do is like a summary of M1 and take a quick glance at some of these. So it's 363 rules, rule length and distribution. So there were, of the 363 rules, 137 of them were of 2 items. So something like item A implies item B. Okay, or said another way, if you buy item A, you're likely to buy item B, something like that. 214 of those rules had 3 items. So something like, if you bought item A and B, then you were likely to buy item C. And 12 of those rules were for 4 items. So something like, if you bought item A, B, and C, you were likely to buy item D. Okay, or maybe if you bought item A and B, you were likely to buy items C and D. That's possible as well. Okay, and then we get a distribution similar to how we did before, and some stats on the support, confidence, and lift. I'll leave out lift maybe till a little later. Okay, let's actually look at some of these rules. So to look at the rules, we can inspect them. Okay, let's inspect M1. Again, if we hit enter here, we're going to see all 363 rules. We don't want to do that. So let's inspect just like the first 2. Okay, so the first rule says that customers who bought herbs were also likely to buy root vegetables. Okay, that rule had a support of 0.007. So here's our arrow here. This is a rule here. We finally got an association rule. It had a confidence of 43%. Okay, and it had a lift of 3.95. Okay, and a lift is simply the confidence over the support of Y. Okay, so you could think of lift as how much more likely an item is to be purchased relative to its general purchase rate. Okay, given that you know that another item has been purchased. Okay, so a higher lift is obviously going to be better. And so we might want to sort our rules to have the rules with the highest lift be at the top, and let's just look at those rules. Okay, so once again, lift is how much more likely an item is to be purchased relative to its general purchase rate, given that you purchased this item with that you know you have this other item that you purchased it with. So how much more likely are root vegetables to be purchased with herbs than root vegetables in general? In other words, in all transactions. So in other words, it's 4 times more likely almost that a root vegetable is going to be purchased with herbs in a transaction that has herbs than root vegetables are going to be purchased in all transactions. So with herbs, it's 4 times more likely that a root vegetable is going to be in there than in the general transactions, all of them. Okay, so that's a pretty high lift. Okay, so let's sort our rules. So there's 363 rules. We can go through all of them, but I don't want to go through all of them here with you. A lot of them will be interesting. A lot of them may be nonsensical and obvious. Let me show you a way to look at some of the maybe more interesting rules to get to the bottom of the most interesting rules. So we can use inspect and we can sort M1. Okay, we could sort it by the lift. You could sort by lift. You could sort by support. You can sort by confidence. Okay, I want to support by lift. Okay, so close. If I hit enter here, I'm going to get all 363 rules. I don't want all 363. Let me just look at the top like 3, or let's make it top 4. Okay, so here's the top 4 rules sorted by lift. So you see the rule with the highest lift was the herbs and the root. Herbs imply roots. Next was berries implies whipped cream / sour cream. Interesting. So customers who bought berries were likely to also buy whipped cream / sour cream. Okay, with a lift of 3.8. So if you bought, okay, so whipped cream shows up in transactions with berries 3.8 times more than in general transactions. That's what lift is. So that's an interesting rule. So maybe we would put berries and whipped cream close to each other in the aisles, or if someone online bought berries, we would also throw a special deal that to get whipped cream at a nicer price, something like that. Next rule here, we got other vegetables, tropical fruit, whole milk imply root vegetables. Okay, that's somewhat interesting. I don't know exactly what I would do with that as a manager. Beef and other vegetables imply root vegetables. Okay, so someone's cooking some dinner, so that's got high lift. Let's look at some more. So let's look at 4 to 10. So that one. Anything interesting here? So a lot of stuff that you would have to kind of think about as a subject matter expert. The most interesting thing to me was actually the berries and the whipped cream. Okay, it picked that pattern up nicely. Okay, and it was the rule with the second highest lift. Okay, so some of these association rules are going to be trivial. You're going to kind of expect them, they're obvious. Some of them are just going to be kind of inexplicable. Okay, you're really looking for interesting things that you can take action on. Okay, especially if you're kind of in the grocery setting or any kind of product recommendation system. You want to think of things that also make some common sense. Okay, also that challenge common sense. All right, so here are the association rules, and this is the end product of doing a market basket analysis. All right. So let me just clean this up and kind of summarize what we've done here. These were my more interesting rules. So we've done a association rules, which is an unsupervised learning algorithm for picking up patterns in transactional data. In this case, it was grocery store, so we did what's called market basket analysis. There's a lot more you could do with this. You could look at rules specific to any particular item or group of items. You could put them on the left hand side or the right hand side and then sort them with any of these and try to see interesting rules that might be actionable for kind of a business setting or whatever it might be. So at least these two parts series that I did on association rules gives you the basics on how to get started with association rules in market basket analysis, in transactional data, using the arules package. So make sure to watch my other machine learning tutorials on the playlist. Until next time, have a great day.